So in this video, I'm going to demonstrate how you can use MATLAB in order for you to parameterize or model the sorption isotherm. So in this activity, you would need to model the water activity and moisture content data using two different established models. We have the BET model and the GAB models. So again, these models allows you to describe the moisture content on a dry basis using the water activity. But notice that there are other parameters in the model aside from the water activity. So for the case of BET model, you have two additional parameters. And for the GAB model, you have three. This one, and this. So the goal of this exercise is for you to feel MATLAB, how to program it. Then it's also for you to parameterize or do identification of the models. That is, you need to give me these three values for the GAB models and these two values for the BET model. And learn to assess the goodness of fit of the model by using this equation. So let's look at the data that you would need to model. So this is the data that you would need to model. So there are 11 data points, so a combination of water activity and equilibrium moisture content. And shown on the right is a figure that I did that shows how this raw data can be modeled using the GAB and the BET model. So I would want to see this kind of figure in your report also. Okay, let's start. So let's start by looking at the things that I would be sending you. So you should be able to receive this BET optimization script in MATLAB and also the AW moisture data. So the raw data is in this .mat file. And also, don't forget that you should also obtain this objective function BET. So the important thing in MATLAB is that everything should be in the same folder. So when you set your current directory in MATLAB, MATLAB knows where to find everything. And ideally, they should be in one folder. So to start with, maybe let's start by copying this folder where all of these necessary files are located. Then now we can go to MATLAB. Okay, so I've already written the script for the BET optimization. So first, as I've said, it is important that MATLAB knows where to get all the files. So here we have this function to set the current directory. So in your case, you would need to change the directory. So notice how this one is constructed. It's like this, CD, and you have this. So you just need to paste the directory here. And for you to run this section, you just need to press this part, run section, or you need to press Control Enter. Then as you can see here on your workspace, there are already some variables, and also here in the command window. So we can clear it out by running this part of the script. So run this section. So it clears the workplace and the command window. Next, we need to load the moisture and water activity data. So the data is already here at the AW moisture data.mat. So we just need to load this one. Then after loading this, we could separate the data into the water activity data and the moisture data. So we just need to run this part of the script, Control Enter. And as you can see here, you have your moisture data here, the water activity data here. And well, this one is a combination. So we separated the water activity and the moisture data. So this is the original combination. Then we have the water activity data here. And if you double click here, the moisture data here. Okay, now that we have the data, we first observe the data that we have. Okay, if you press Control Enter here, so you see the behavior of water activity and the moisture content for the 11 data points. Now, so this is what we need to model. So modeling the data based on the BET model. So we first set the X data to be our water activity data and the Y data to be our moisture data. Then X naught here would be our initial guess for the two parameters that we need to identify for the BET model. So here I set 0.10 for the first parameter and 20 for the second parameter C. Now, we set the objective function for this one. So what is the objective function? So we have a separate script for the objective function. And if we look at the objective function, we see here that what is this one? So essentially the objective function is a function that helps us minimize the error between the model and what the actual data is. So essentially the best model would give you the one with the lowest error. So first, what is the equation that we're using for the BET model? So this is the equation that we're using for the BET model. And we want to compare this. So MATLAB would choose different values for x1 and x2 because you have two parameters and compare it with a combination of this x1 and x2 with your experimental data. So that is why this is the objective function. The objective is to minimize the difference between the moisture simulated and the Y data. So let's change this. So this is the BET model. Okay. Now, for us to do the parameterization or identification, we use the fmin search function. So for this one, it would require you to input the objective function, which was already indicated here. And we also need to input the initial guess here. So we just need to run this part of the script. And if we want to see this one on a table, we run this part of the script and we see here that you see that this one is the guess for these parameters and this is what MATLAB found. Next part is to compare the experimental and the model. So this part just plots the experimental data and this part plots the model. So using the optimized unknown parameters, so now you know these two parameters and using the BET equation, then we could do this plots. And you can see here the model compared to the experimental data. So to calculate the error of the calculation, then you need to compare what is being projected by the model and what you have as your experimental data. So we have this equation, right? And if you want to get the average, we just calculate it using this equation. And if we run this part, what do we get? The average error using the BET model is 7.83%. So the task now is for you to implement this kind of script for the GAB model. So you need to make an objective function for the GAB model and also you need to optimize this for the GAB optimization. So I hope that this will help you implement this part of the practical session, and if you have any more questions, you can email me or the other instructor for this one.